So let's continue our discussion about using truth tables to understand how Boolean operators work and what the result is on a Boolean equation, if you will. And let's go ahead and move on to this second truth table here, where we once again have the same combinations that we had up here, but we've got some more complex Boolean equations going on here. But it's really not that much more difficult. It basically, the hardest part here is keeping your order of operations straight, and you can go through these rather quickly as well. In the case of this first row here, we've got the exclusive OR inside the parentheses, and so we need to do that first, and then we have a not on the final result. So all we're going to do is basically calculate what the exclusive OR on A and B is going to be, and we've already calculated that to false, right, inside this expression. But then we know that that also is going to have a not on it, so we know a not on false is equal to true. So the final result of our equation here is going to be true. We can do the same thing down here, where the exclusive OR on these is going to be true, because we know, as we saw up here, right, that an exclusive OR on a false and a true is true, and then of course we've got the not in front of that, which is going to make this whole equation false because the not inverts that whole thing. Let's go ahead and move on to the second one here. We've got a not on the first variable and a not on the second variable, and we also have an and going on. So it's kind of simple in the fact that we just basically perform the not on the variables first. So a not on a false and a not on a false is going to be true. So now what we're basically evaluating here is an and on two trues, which, as we noticed up here, on two trues is equal to true. Down here we're going to do an and on the not of f, which is true, and the not of true, which is false, which basically ends up being a false overall for this one. Similarly here, as we did at on the first one, we have an OR on A and B, which are both false, which ends up being false, and once again we do the not on that, and that's going to equal true. And then down here, an OR is going to evaluate to true on these ones because of as we, one of them is true, and we do the not on that one as well, which equals this whole thing. The final result is going to be false. We'll go down here and just look at this one as on this as well. Same here. We do the OR on A and B. The OR on A and B is going to be true because one of them is true, and we do the not afterwards, which makes the whole thing evaluate, to down here to false. So before we move on, I just want to show you real quick. When you have three variables, things get a little more complicated, but not so much. It's just a matter of keeping the different things straight in your head and doing the order of operations first, meaning, the A and B. This one I thought was kind of interesting because you notice that overall things look pretty much the same. We've got an OR and we've got an AND. Over here we've got an OR and an AND, but we've got the parentheses in different places, so I thought that would be useful to show you the importance of the order of operations. So we'll go ahead and evaluate the first line here, which the first thing we evaluate is the what's in parentheses, and we have an OR on the A and the B, which OR on the A and B is going to return true. And then we know that C is true. So in essence what we're doing is an AND on two trues, which, as we saw in the first truth table, is going to be true. Over here, similar, we know that we're going to end up basically with true as well, because we know that an AND on both trues is going to return true. And we have a true anyway on this OR, which means when we have an OR and we know that one side is true, then the whole thing is going to evaluate at true. So just to make things a little more interesting, well, we just keep moving on a little bit here. So here we'll do the same thing. The left side inside the parentheses, the OR on the A is going to evaluate to true because both A and B are true. And then the AND is going to evaluate, or C we know is false. So now we're doing an AND on true and false, which, as we saw in our first truth table, is going to be false because an AND requires them both to be true in order to return a true. Over here we have an OR on this side and an AND in here. And the AND is going to evaluate to false because we know that B and C are not. One of them is false, so that's going to evaluate to false, but we know that A is still true, and in an OR, as long as one of them is true, the whole thing evaluates to true. So here you can see that we've got different values going on as a result, basically because the order of operations are different. So, and then you can go through the rest here and do these on your own to understand these a little more surely, if you will, to get a little firmer grasp on these. But that should give you a little bit of a better understanding on truth tables and how they work.